Well, hello Internet, and welcome to my updated Swift 3 video tutorial. In this one video tutorial, you're going to learn the core syntax of the Swift 3 language through a ton of example code. Basically, it's like seeing a 300-page book in one video. And like always, in the description, I have a link to all the code as well as a transcript of this video. And also you'll find there timestamps to all the individual things that I'm covering. So there's no need to watch the entire video all at one time. You could watch up to a certain point and then go back, click on a timestamp, and learn everything you want to know. And I have a lot to do, so let's get into it. Alright, so probably one of the first things you want to do is verify that you have an updated version of Swift. So one way you can do that is just in your terminal. You can go xc run swift and dash version. And you can see right there, I have Apple Swift version 3.0.2. There's no difference between 3.1 or any of these other different things. So I have an updated version of Swift. If you do not, you're going to want to open up the App Store and go and download Xcode for free or update it or whatever. And then you will be all set and ready to program with Swift. Once you do, what you're going to want to do, if you want to do what I'm doing, is go File and New, and then come down here and click on Playground. And specifically, we are going to be developing for Mac OS, but Swift is the same everywhere. And then give a name to your playground and click on Next. After you do that, you're going to see a screen that looks like this. Right here is where you're going to put all your code. Over here is the playground area that's going to output data as you are placing it in there. And then down here is going to be the console. Just to get some things out of the way, this is a comment, and this is a multi-line comment, and like that. And now let's start writing some real code. So the very first thing I want to do is import Coca. And this is going to give us access to the Coca framework that we're going to be using here. And also I am going to import Darwin. And this is going to provide a whole bunch of random functions that I'm going to need whenever I'm writing code here. Var is going to be used to declare all of your different variables that the value could potentially change. So what I'm going to do here is just define hello, which is a string, of course. You could also come in here and define that, in fact, it is a string just by putting a colon in there and string. But otherwise, it's going to know that just based off of the data that you provide. Of course, you're going to be able to come in here and easily combine strings. So let's go hello plus world. And you're going to be able to print to the screen just by coming in here, and you could go hello and a backslash and whatever variable you want to print out. And you can see over here on the right side of the screen, everything's printing out, and over here at the bottom, everything's printing out all at the same time. And now that I got the basics out of the way, I'd like to talk about data types. Now, let is going to allow you to define a constant. So let's come in here and define a constant right like that. You're also going to be able to declare integers, and I'm going to get into all the different data types here. So let's say my age, colon, and int. That just means it's an integer. You're going to be able to see the minimum and maximum values you're going to be able to store inside of here. So I'm going to say min int, and I'm going to be working with 64-bit ints. So let's go and get the minimum value, and then let's also go, and you can see right there that value, and let's also come in here and let's get the maximum value. So we'll just put max in there, and then max right there. So there you go. Now you have the minimum value for integers as well as the maximum values. Now let's come in and define a float. I'm just going to use pi again here, and float. There we are. And likewise, you're going to be able to define doubles. So come in there like that, and double is equal to 3.415. Just keep it the same. And let's go and get the minimum max for our doubles. So let's just grab this guy right here, paste that inside of there, and let's change this to max double, or min double. Let's do min. So min double, and then to get that, you're just going to replace that guy right there with dbl, and then you have to replace this all together. So just put underscore and min, and then we're going to also get the maximum double. So maximum double and max. So there you go. Now you can see the minimum doubles as well as the maximum doubles. If you want to get the maximum float, you have to do something a little bit weird. I'm going to show you how to do it. So max float backslash, once again, if you want to put anything inside of there. So you go float, and then you're going to say greatest finite magnitude, And there you go. Now you're going to be able to figure out the greatest or the largest float that you can use inside of Swift. And let's talk about some booleans here next. Booleans, of course, are going to be able to hold only true or false values. So let's go and have can vote and boolean is equal to true. You're also going to be able to have characters. So let's go my grade and character is equal to A. You're going to be able to cast different values. So let's go and have 3 and define it as a double, 3.0, and then have var 2 and have it be an integer equal to 2. And then we'll go and create 5 equal to 3 plus, and I'm going to do it the wrong way without the casting just to show you that there is an error. So 3 plus 2 is equal to 5, and you can see everything went haywire down here. The reason why those two different data types. If you want to fix that, just come in here and go double like that, and there you go. Now you're going to be able to work with those. And likewise, you're going to be able to cast 2 integers. So we'll go print, and I'm going to go throw a 3 inside of there like that, and backslash, and convert to an integer, of course, and then we'll throw 3.14 inside of there. And you can see that that all worked. All right, so there's just a rough overview of using variables and different data types, and I'll be covering a lot more in multiple different examples. And now I want to talk about conditionals. So you're going to have a bunch of comparison operators I'm sure you're aware of. You're going to have greater than, you're going to have less than, you're going to have greater than or equal to, less than or equal to, and not equal to. Likewise, there are 2 additional ones. You can have 3 equals, and this is going to check if the 2 things being compared are pointing to the same reference. And then this is going to check if they are not pointing at the same reference. Okay? Now let's talk about if. So let's go and create a age variable, and it'll be int, and give it a value of 8. And then what I'm going to do is, depending upon different conditions, I'm going to come in here and do different things. So I'm going to say if the age is less than 5, in that situation, I want to print to go to preschool. All right, got all that set up. Else, if, and here we're going to check if the age is equal to 5. In that situation, once again, we're going to print out go to kindergarten. All right, and likewise, else if, and here I'm going to use a logical operator called and I'm going to say if the age is greater than 5, and both of these have to be true for this condition to pass on. Age is less than or equal to 18, and you can see the curly brackets are just surrounding all the code that is going to go along with that condition. I'm then going to come in here and calculate grade. So go integer is equal to age minus 5, and then we'll come in and print out that information. So we'll say go to grade, and then go and get whatever the value is that is stored inside of grade. And then we will have our final default, and in this one I will just say everybody else go to college. All right, and you can see the answer is actually go to grade 3. I'd already put it down there, and there it is down there. All right, so just a rundown of those guys. Let's go and talk also about the OR logical operator. So I'm going to say that I want to calculate if somebody is going to qualify for a college grant. So I'm going to create a double here, and I'm going to put in 12,000, and I'm also going to put in a GPA and make that a double also, and we'll just have it be 3.7, and then we're going to say if this person qualifies for a grant. So we're going to say get grant and throw that in there and put this in here and put that there. And we're going to say income less than 15,000, or, so either of these can be true, GPA greater than or equal to 3.8. And once again, you can look over here to see the output as well as at the bottom. All right, so that's how the logical OR operator works. And let's also talk about the NOT operator. Basically, the NOT logical operator is just going to turn all trues into falses and all falses into trues. So we're going to say not true, and we will throw not inside of there, and there we go. So there we are. Now you can see all of the different ways of working with both the comparison operators and the logical operators. Now let's take a look at the ternary operator. I'm going to keep age inside of there for a couple examples. So I'm going to go in here and say can drive. And what the ternary operator is going to do, it is going to assign one or another value depending upon a condition. So here I'm going to say if the age is greater than or equal to 16 and a question mark, if that condition is true, then can drive is going to be assigned a value of true. And you can use things other than true and false. Of course, you could have these be numbers or whatever you want. And you can see there the answer is false. So that is a basic ternary operator. So now let's look at the switch operator, which is basically used to match a limited number of values. And one thing that is important to understand is if you do get a match, that doesn't mean that it's going to fall through after that match. You're only going to have one match unless you use something called the fall through, which I'm going to show here in a second. So let's say we have an application that is going to allow you to define that you have an ingredient, and then it's going to give you recommendations on the type of things you can eat with that ingredient. So we'll go switch, and it's going to check for the values of ingredient. And here what we're going to do is we're going to say that in the situation in which they say they have tomatoes or they have pasta, we are going to say that's a match. So that basically works that way. Let's get rid of that. Oops. Let's put the double quotes around that. Okay, there we are. Now we got that set. So what we're going to do here is just print out a recommendation for something they can eat. So I'm going to say spaghetti, and there we go. So they got a recommendation. If you would want it to continue, not only it's not even going to verify. Well, let me do this first. So let's come back here and we'll say case beans, and maybe I'll just show you an example rather than talking about it. So in this situation, we're going to come in and say burrito is an option in that situation. And I'll hold off on the fall through until I get all this done. Likewise, you could say potato, potatoes, whatever, and print out mashed potatoes. And then finally, you're going to have a default that is going to run if nothing else runs. And in this situation, if the person doesn't have any of these things, we're going to say, go drink a glass of water. All right. Now you can see spaghetti comes in right there. If I wanted it to fall through and execute the next thing in line, even if the condition isn't true, I would type fall through inside of there. Fall through, and you can see burrito went in there, even though my ingredient is not equal to beans. Okay? Not something you use all the time, but something I wanted to cover just so that I could say that I covered everything. Let's get rid of all this. You're also going to be able to use switch to match ranges of different values. So let's come in here and let's go test score and int equal to 89. And then it is going to go and score this. So we can say check the values of test score. And here we'll say case. And we'll say 93, 123, and 100. So in the situation in which it's equal to 93 through the value of 100, we're going to come in and go print, you got an A. All right. And then likewise, you could do similar things with all of the other different values. So there's no point in me really doing that. And otherwise, we'll come in here and we'll say default, and we'll say print, you got an F. All right, so I'm not very happy. Oh, it actually comes back as you got an F, but whatever. I'm just going to change this to 93 so that everybody can get an A. All right, makes everybody feel better. All right, now it's an A. All right, so of course you can come in here and do case through all the other different ranges, but I didn't want to waste time on that. So now what we're going to do is we're going to go in and talk about some math functions. Now there are all of the basic math functions that you're probably aware of. So we can do addition, of course. And likewise, we're able to do subtraction, multiplication, division, and modulus. If you've ever heard of modulus, it is going to return the remainder of a division. And you can see all of the output that we have over here, okay? Very important, however, if you do not do division with doubles, which means if you just put 5 and 4 inside of there, it's going to give you an integer result. So you get a value of 1 back there. So it's just something to be aware of. So make sure that you do that. Another thing that's important is order of operations. So I'm just want to show you exactly how the program figures this out. So let's say you have 4 plus 5 times 10 is equal to, and let's figure out how the computer figures this out. So we'll go 4 plus 5 times 10. All right, and that gives us a value of 54. Well, that doesn't make any sense unless you understand that computers are going to give more weight to multiplication than addition. So instead of adding 4 plus 5 to get a value of 9 and then multiplying that times 10, what it does instead is multiply 5 times 10 and then add 4 onto it. Of course, if you want to fix that and have it work in a different way, you just put parentheses around it. So throw our parentheses like that, and like that, and like that, and there you go. Now you will get the results that you were expecting, and 90 shows up over there. So real quick thing. Another thing that's important is there are different shortcuts available for you for adding. So let's go and go random num and make it an integer equal to 5. You're going to be able to come in here and go random num plus equal to 1, which is exactly the same as if you would type out random number is equal to random number plus 5 or plus 1. Okay, so just a shortcut that's available for you. And likewise, you would be able to come in here and do subtraction and so forth and so on. You can see the results over there. For some reason, you used to be able to come in Swift and go plus plus to increment a value. For some reason, I got rid of that. Don't know why. So that's gone, not an option anymore. Likewise, there are a whole bunch of built-in different functions inside of here. You can find the absolute value, floor, which is automatically going to round down, ceiling, it's going to round up, no matter what the decimal is. If you pass in two values, max is going to give you the maximum, min is going to give you the minimum. You're going to be able to find 5 to the power of 2 or what have you. You can also calculate square roots and logs and a whole bunch of other different things. And of course, there's all of these guys down here if you'd like to use those functions. Okay, so quick rundown of a whole bunch of math functions. Now I want to talk about strings. Okay, so strings are a little bit weird inside of Swift, but I'm going to try and clear everything up. Very first thing I want to cover, though, is there are certain escape characters. So you're going to have 2 backslashes. If you want your backslashes to show up in a string, you're going to have to do that. This is a tab. This is a new line, which you've been seeing. Double quotes, and then you're going to have single quotes. Okay, so there's just a couple examples of some escape characters that you'll have to use in your strings. Let's go and create some strings. So I'm going to go random string equal to, and then I'm going to say this is a random string. And let's go and create some more. So I'm going to go and create another random string, and I'll show you some different operations you can perform. And we'll say, and here is another. All right, so there we go. We got 2 strings to work with. Now, of course, I talked about before how you can join strings. So let's create another one. Let's go random string 3 is equal to, and then we'll go random string plus random string 2. And there you go. You're able to join 2 strings that easily. And if you want to get the string length, it's pretty easy. You just go length like this. And we do our little backslash, and then we put in whatever we want to measure. So we'll go random string 3, and then you're going to say characters, and then you're going to say count. And that's how you can get the length of a string. You're going to be able to get the first character in a string. Let's go this. Let's just call this first backslash. And we'll do random string 3 once again. And to get the first character, you're going to say random string 3 and start index. Say it's a little bit weird, but we'll get used to it. You're also going to be able to get, let's say you want to get a very specific index. Let's say we want to get index 5, whatever stored in index 5. Let's go and create that guy. How you're going to get it is go random string 3 followed by index, and then you're going to say where we are starting from when we are searching through this string. So we're going to start at the start index and then offset by and 5, and that will get you to the 5th index. And then we can go and print it out. So let's just go 5th and random string 3. It is very common for people to go in and write their own ways of operating with strings inside of Swift so that you don't have to type all that out. You know, kind of a little bit crazy. Whoops, I have to surround this, otherwise it's not going to give me what I want. All right, there we go. And it comes back as I. All right, so that's how we would get like a specific index inside of a string. We could also check if a string is empty or not. So we'll go empty and just do a backslash, and let's work with random string, just a random string, doesn't matter which one I use. So empty, and that's going to give me a true or false value. You're going to be able to insert characters at a specific index. Let's go and work with random string 2 now. And you're going to say insert. And let's say I want to put capital letter A inside of there. I'm going to define what I want to put. And then I'm going to say at and random string 2. And let's put it at the very beginning. So start index. There we go. We're going to be able to replace that string, or the very beginning of it. If I spell insert right, that is, insert. Okay. You're also going to be able to insert a string at an index. So let's go random string 2, insert, and then you're going to type in contents of, and this is going to be what you want to insert. So I'm going to say, just to put a space and a string inside of there, and then throw another space there. Then we're going to follow that up with dot characters, comma, and then you're going to say at, and then you're going to define your string. So let's just go down to the next line. So we'll go like this, string 2, or you're going to define your index. So you're going to index. Once again, you're going to do pretty much the same thing. String 2, start where you want to start, which is going to be the start index. That's normally the easiest. Offset by, and let's put this in the index 2. And there we go. And now we're going to be able to go print and random string 2. And there you can see a string, and here is another. Okay. And I put an extra comma or an extra space in there I didn't need to. Whatever. Doesn't really matter. And there you can see we got the proper results. You're also going to be able to come in and get substrings. So I'm going to go let start index, where I want to start getting my data from. And let's use string 2 again. You can go index random string 2 and start index, and this is going to define where I'm going to start defining this string that I want to work with or get a substring of, offset by, and then in this situation I'll say 2, and then you need to define your ending index for your substring. So I'm going to go end index, and let's just go and copy this and paste that inside of there, and then everything else can be fine. And then I'm going to say 9 is the ending part where I want to grab from, and then we can go, let's call this string range, so we're seeing it's good, and go start index as in a space dot dot less than sign the ending index, and that's going to pull all that in. Oh, I don't think I said this or not, but you don't need to use semicolons inside of Swift. So then we'll go let substring equal to random string 2 dot substring. You'll say with string range, and there you can grab your different substrings that you have, and you can see that it grabs string out of that string that we defined right there. You're also going to be able to replace a string. So what you want to do first is check if there is a match. So we're going to go if let here match, I'm going to call this equal to random string 2 and range. And what I'm going to look for is the word here. So what I'm doing is checking if there is a match for the word here inside of that string. And in the situation in which there is, I'm going to go random string 2, replace subrange, and I can say here match, and it's going to match that guy, and it's going to replace it with there. Well, put it inside of quotes though, right like that. And you can see, oh, let's move this over here, a string, and there is another. Okay, so you can see that it went in there and replaced that value. Okay, so there's a rundown of a whole bunch of different things we can do with strings. Now let's talk about arrays. Now, of course, arrays are going to store values of the same type. So let's go and define an empty array here just to show you that you can do that. So just go like this, and we're going to define that this is an integer array. Okay, so there you go. You got an empty array. You can check if the array is empty just by going in here, and we'll go empty like that, and backslash, and then whatever your array name is, followed by is empty. And of course, put these parentheses around this guy, right like that, and you will get your results that you expected. And there you can see that it shows that it's empty. You're also going to be able to append values to your array just by using append, and there's 5. You're going to be able to add multiple items. So let's go array 1 and then go plus equal to. You can add 1 or you can add a whole bunch. So 7 and 9, there you go. Of course, you're going to be able to get the different indexed values. So let's say we want whatever is in index 1. We can get that as well. Array 1 just by using this notation. You're going to be able to change values inside of the different indexes. Let's just have 0 right there and change it to 4. You can also insert at a specific index. So let's say that we want to put 10 in the index of 3. Just go at 3. And of course you can remove items as well. So remove at, and then let's just get rid of what we just put inside of there. It's also very easy to change multiple different values. So let's say array 1, and we want to change the 0 index through the second index and put these new values inside of there. We can do so. We can get the length or the number of items inside of our array. It's just by, let's go length and whatever your array name is and use count. You could fill your array with a specific value. So let's go and create a brand new array is equal to array and repeating and whatever you want to be put in there, and then follow that up with how many times you want it repeated. So that's going to put 5 zeros inside of our array to start off. Of course, you're going to be able to combine arrays just like you did with strings previously. So array 1 plus array 2. And this is a for loop here that we're going to use to iterate through an array. What you're going to do is item is temporarily going to hold each value of the array, and it's going to do something with it. In this situation, it's just going to print that item out. And you could also get the index and the value if you would so like. We'll just put index inside of there as the name for that, and value. And then follow that up with array 3 and enumerated. And now we'll get both of those guys. So let's just keep this simple, and we will just put inside of here index with a colon, and then go and get the value as well. And there you go. You can see here, whenever you're doing looping inside of Swift, over here in the playground area, it's telling you how many times it's looping. And over here at the bottom, it is actually outputting all of your data. Okay, so I'm talking a lot about looping. Why don't we go and do some more specific example problems using looping. All right, so we're working with arrays. Let's go and create another array. And let's just give this a value of 1, 2, and 3, just to keep it nice and simple. Now, of course, you're going to be able to iterate through your array. I'm going to do it again here, just in case somebody skipped to this. So we'll go array 4, and then we'll print out all of the different values for our array. We're also going to be able to iterate with a range. So we'll say for I in, and then whatever your range is, 1, 2, 3. And let's go and print all of that out. We can also use the where clause to get different results. So we'll say for I in, and we'll use a range here once again, 1 through 10. And I'm going to set the condition that the only thing that's going to print out are i's in which we take the modulus of 2 and get a value of 0. So what this is going to do is print out all even numbers. And you can throw any condition in there that you would like. So I'm going to go even, and then get the matches for that. And you can see it only printed out the even values. And that's a pretty good rundown of 4. We're going to do more with 4 as the tutorial continues, but now I might as well take a look at the while loops. Now with while loops, you're going to come in here and you're going to have to define whatever you're going to be iterating over outside of the while loop. And then you're going to follow that up with while and whatever your condition is. So I'm going to say, as long as I is less than 10, I want to continue looping. Here, I want to show you how continue works. Let's come in here and check to see if this is an even number or not. So we'll say I modulus 2 is equal to 0. In that condition, what we're going to do is increment the value of I and then say continue. And what continue is going to do is it's going to skip the rest of the stuff that is inside of the loop and come up here and start looping again. Okay, so that's continue. Likewise, let's say if we want to check if I is equal to 7, and in the situation in which I is equal to 7, we want to jump completely out of the loop down to here. Whatever code follows after this, we would just type in break, not brack, break. All right, so there you go. And of course, to make this work and actually do something, we'll say print I, and then we will also increment the values of I. And there we are. Now we're able to go through and it prints out only the odd numbers, and whenever it gets 7, it breaks out of the loop. That's the reason why you don't see 7 there. All right, so rundown of while loops. Why don't we take a look at repeat whiles? All right, so let's do something a little bit more interesting. Let's generate a random number. How you do that is we go, I'm going to call this magic number, and this has to be an unsigned 32-bit integer, and we're going to call arc for random, and uniform and 1 through 10 is what we're going to be searching through. And then we're going to say guess, and this is going to be an unsigned integer as well, 32. And then we're going to say our first guess of what this random number is 0. And now let's get to the main part. We're going to say repeat, and what this is going to guarantee is we're going to go through the loop at least one time before the condition is checked. So we're going to go through, and we're going to put down our guess, whatever that guess, well, it's going to start off at 0 and it's going to increment from there. So there is our guess, and then we will go and get our guess and increment it by 1. And then after this, we're going to put our condition. We're going to say, wow, the magic num is not equal to the guess. We want to continue looping forever. And then we can come out of here and then we'll say magic number was, and we'll put in the magic number just to show that they guessed it. And you can see right here, it went in and guessed, and it came back with a value of, it checked for 0, 1, and then we found out the value was actually 2. And now let's take a look at dictionaries. Now basically, dictionaries store unordered lists of key-valued pairs. And let's come in here and let's create a dictionary here first. It's just going to be an empty dictionary. And we're going to define that the key is going to be an integer and the value is going to be a string. Now we're going to be able to check if it's empty, of course, in pretty much exactly the same way we've always checked if things are empty. Dictionary 1 and is empty. Whoops, make sure you put in your backslash, and there we go. Now we got that back as true. We're going to be able to create an item, and let's say we want to assign the index of 1 to it. We can do so. Let's go, or the key of 1. We'll just go dictionary 1 and put that key inside of there is equal to, and then we'll put something like Paul Smith inside of there. So you have an integer and you have a string. You're also going to be able to create a dictionary with a string key. So we'll go customer colon, and we will go string and define all this. And so these have to be strings now, colon, and then we'll say something like Sally Marks. And then let's go down to the next line and 2, and then let's have this person be Paul Marks. Okay, so there you are. It doesn't matter what your keys are, your values, or anything like that. We can get the size or the number of items that are stored inside of here, exactly like we did previously. So we'll go customer and count, and that's going to give us that result that we're looking for. You're going to be able to come in and add different values. So we'll go customer, and here we'll say that the key is going to be equal to 3. And let's change this to Doug Marks. You're going to be able to change values exactly the same way. Just go like that. And let's change this to Doug Holmes. You're going to be able to get values. So what we're going to do is say if let name, and we're going to verify that the key exists. So customer and 3. So if that exists, then we're going to print out some information on it. So we'll go print, and here we'll change this to index 3 and go and get the name out of there. Whoops, put a little error inside of here, change that comma up there into a colon. All right, got that fixed. You're also going to be able to remove a key value pair just by assigning a value of nil to it. Just go and whatever you want removed altogether, just put nil inside of there. And of course, we could iterate through a dictionary. So let's go for, and let's say we want the key and the value. Of course, we can get that. Hit customer, and then let's just output them on the screen. So there that is. And let's go and get our key and get our value. And there you can see it went and outputted those. So there's a rundown of a bunch of things we can do with dictionaries. Now I want to take a look at tuples. So let's come in here. Basically, tuples are a finite group of values that the values are going to be related in some way. So let's go and let's define a constant height and say it's a double and put 6.25 inside of there. And then we'll go define another one for weight. And we'll say this is an integer. You can use different values, different data types. And let's create a tuple. So I'm going to call this my data is equal to, and throw height and weight inside of there. But we have to surround this with parentheses. And there's that, and there's that. Okay, so we have that set up. There's a tuple. We're going to be able to access these values, of course. So let's go and get height, and let's get my data out of there, my data, and 0 is going to get you your height. Change that to uppercase, of course. You'll also be able to name values. So let's go let my data2 is equal to, and throw height inside of there, and then 6.25 and weight inside of there. And there that is. And just to verify that that works, we can go print and weight, and there this is, and we'll go and get my data2, and now you can use weight instead of an index. All right, so just a very brief overview of tuples. Didn't want to do too much with them. And now we'll go in and talk about optional. Now basically, optionals are used to indicate that there may not be a value. So everything that can have a value of nil should basically be declared an optional. And this is a great way to avoid a whole bunch of different errors. So how you declare an optional, let's say var political party. All right, this is something that somebody may or may not have. And how you define this as an optional is you put a question mark at the end of it. Now we can come in here and go political party. And we'll say that this person decides to say that they're independent. All right, so there's independent assigned to that. Doesn't have to have a value, could have a value. So if we want to check to see if it has a value of nil, we can go if political party is not equal to nil. Well, in that situation, we want to get the value. And this is called forced unwrapping. So how we get the value, let's call this party, is we go equal to political party, and then to unwrap it, to get the value, you put an exclamation mark at the end. And after you do that, you're going to be able to come in here and actually print this in, or print this out. So we'll just go and get the value of party. And there you can see independent showed up. But it wouldn't cause any havoc if anything wasn't in there. It would have just been caught right here where we checked if it has a value of nil. Now you also have optional binding, and it is used to check if an optional has a value. So what we're going to do is go if let party equal to political party. Boy, I think I could have picked something a little bit easier to type. Either way, political party. And then we can say print party and go and get that value. And there that is. Otherwise, we will say else and just print no party. And that's set. And you can see independent once again gets printed out on the screen. Another thing you can do is if a value is set for nil, you can use what's called a coalescing operator to assign a value. So we'll say let party equal to political party, and then throw 2 exclamation marks inside of there. And in that situation, if it does have a value of nil, it will assign the value of no party. Otherwise, it will just be ignored. So there's optionals, and now I'd like to talk about functions. Now, whenever you define your functions, let's call this one getSum, you're going to have to define whatever the data types are for your parameters that are passed inside of here. So let's go num2 and then define this as an integer. And then what this guy can do whenever it's called is output sum and sum whatever values were put inside of it. So we'll go number1 plus number2. Now, of course, to call the function, all you got to do is go get sum, like this, and then you're going to go and assign whatever you want inside of there. So I'm just going to go like this, and I'm going to change this to a value of 5, and then I'm going to change this to a value of 6. And you can see it printed all that out on the screen. You can also define your return type and even define default values. So let's go function. Let's just use getSum2. And then we're going to define this. You can use the same names inside of the functions. They're self-contained. So let's have this be an integer, and then num2, and have it be an integer. And let's give it a default value of 1 if nothing's put inside of there. If we want to define that we return an integer, that's how we do that. And then in this situation, we can just go in here and go return num1 plus num2. All right, so now that function's all set up. And then we can come in here and go and get this guy. So there we are. And you can see it gives it optional whether I put both of them in there or not. I'm going to say that I want both of them in there though. And then I am going, whoops, it's just returning a value. So what I should do here is print this out, of course. So I'm going to say sum, and then we'll copy this right here. So we'll go get that out of there, throw that in there like that, paste that in there like this, and then change this to a value of, I don't know, let's just throw 8 in there and 6 inside of there, and then close that parentheses. And there you can see we got our result. Another thing that's neat is we have things called variadic parameters, and what they're going to allow us to do is to receive an unknown number of parameters. They always have to be last, however, in the list. It's very important, the last parameter passed. So what we're going to do is go function and get sum3. And here, I'm going to define nums and int. And if we're going to get it an unknown number, we'll just throw int inside of there like that. And then we're going to return an int. Here we'll go and define sum and integer is equal to 0. And then we'll cycle through our results. So we'll go for num in nums and get sum and add on whatever the value of num is. And then after we're done with all that, we will return the sum. Pop out of here and let's call our function. So we'll go print and sum and get sum3. And then to define that you pass in a whole bunch of different values, you're going to go nums like that, and then go 1, 2, 3, and 4, and 5 seems to be good enough. And there you can see we got our results. So that works off good. You can also nest functions. However, it's important to remember that the function that is inside a function can only be callable by the function that surrounds it. So I'm going to go function do math and number1, and this receives a double, and number2 also a double, and this guy isn't going to return anything. And then I can put another function or nest another function inside of it. Let's call this mult, and it is going to return a double. And we can just go return, oh, let's just do divide instead. There we are. There's divide. And then we'll just go number1 divided by number2. Works good enough. And then we'll go print inside of this function, outside of the enclosing function, and divide, and then we will call it. So divide, throw that right there. And it's also going to be able to access num1 and num2, of course. And close that guy off. Then outside of this guy, we're going to go do math and then pass in these different values. So I'm going to say that I want to put in here a 5.0 and I want to put 6.0 inside of there. And there you can see we got our results. All right, there's more to do with functions. You can also return multiple values. So I'm going to show you a demonstration of that. We'll go 2 mults, and this is going to receive an integer, and then after that it is going to return multiple values. So we're going to get 2, which is going to be an integer, and 3, which is also going to be an integer. We will define those. So 2 is going to be an int equal to number that's passed inside of it multiplied times 2. Likewise, we're going to do a similar thing with 3. You can see it this goes a little bit haywire down here while you're typing in code. And just ignore it. Is equal to. And this is going to be whatever the number is multiplied times 3. And then to return both of those values, we just go like this and like this. Now to verify that that actually works the way that we think it works, let's go let malts equal to 2 malts, and the number we're going to pass in is going to be num and 2 to demonstrate how that operates, and then we will output it, and we'll go 2 malts and get the value for that. And how you get it is go malts followed by 2, and we'll throw a comma inside of there, and let's go and just output the other one. So malts and 3. Whoops, I had a little error there. Change that to uppercase, and there you can see. All right, so pretty cool stuff. Now I'm going to talk about closures. Okay, now closures are pretty cool. They are functions basically. However, they don't require a name or function definition. So let's create one. It's interesting. So I'm going to create one called square, and it is going to accept and return an int. So I'm going to define int, and you can see there's no name assigned to that, and it's going to return an int. And we'll go equals to, and then I'm going to say num in return num times num. So it's just going to multiply a number times a number. And now we can come down here and play around with it. So we can go print and 5 squared and call it. So we'll say square and throw 5 inside of there. And there you can see, went and performed that. Let's do something a little bit more interesting. Let's assign a closure to another variable. And it's also possible now to assign this closure to another variable. So we can say square copy is equal to square, and it's going to work in exactly the same way. Let's just go and copy this guy right here just to show that it is the same. So square copy, and there you go. You get exactly the same results. And let's do another one. Let's create ourselves a list of numbers, and let's unorder them. So I'm going to go 8, 9, 2, 4, 1, 0, and 7. And you're going to be able to access these values outside of the closure. So let's go and create a function that's basically going to return a Boolean that's going to state if one value is greater than another value. So we'll go sorted nums equal to numbers followed by sorted, and then we can go by and then go x, y, in x less than y. Now what we're going to be able to do with this is come in here, and that's going to automatically sort all of the values for us. So let's go in here and prove that that works. So sorted nums, I'll give you more examples here, and print out those values. So whoops, just throw I inside of there, and there you can see it went and sorted all those values for us. All right, so really cool stuff. Let's do more. Let's say we want to square every item in an array. You can do that with something called the map function, which works with arrays. So we're going to go squared nums is equal to numbers map, and then we'll go num int string in, and then we will return that. Well, let's get rid of that. What did it do that for? String in, and return that value as a string. So we can just go num times num, exactly like that. And then we can come down here and go squared nums. And there it is, and there it went and multiplied all those values times themselves. All right, let's do more. Actually, just thought of something. Did you know you could also return a function from a function? Let's call this function maker. Value integer, yeah, that's good enough. And it's going to return an integer, int. Okay, so we're going to create a function inside of here. Call this add values, and it's going to get num1 int and return an int, return num1 plus whatever the value is. And now what we're going to be able to do down here is return add vals. So what we're in essence doing, oh, I don't need to do that. Get rid of that. Xcode gets ahead of itself here a little bit. What this is a function generator. Well, let me show you the example and it'll make more sense. So we're going to go let add 4 equal to function maker, and then val and 4. So what it's going to do is basically create a function inside of here that is going to add whatever to 4 in this situation to whatever other values are inside of there. So let's go and give you an example here so you can see exactly how it works. So we could say print and 4 plus 5 is equal to, and add 4 to 5, and you can say that it went and got that result. So it basically generates a function inside of a function and returns that function. And this function we told it to generate for us was a function that automatically adds 4 to whatever is passed inside of it. And of course you could change that to 5 and it would add 5, you know, whatever. Just something that came to mind, something kind of neat. So that's how you return functions. You could also pass a function as a parameter. So we're going to go function. Let's call this doMath2. And I'm going to put an underscore inside of there. So I'm going to go mathfunc, gets an integer and an integer, and returns an integer. Whoops, get rid of that parentheses. And this also receives a value that is an integer. We can then go print and sum and call the math function that was passed inside of it. And go value and value. All right, and we'll run it down here and it'll make a lot more sense. So I'm going to go function, add nums, and it's an integer, another integer, and it returns an integer. And all this does is add those two values together. So there we are. And then we're going to pass those into the function and then have them work with it. To do that, we go doMath2 and pass in add nums followed by a value and 5. And you can see it comes back with a value of 10. All right, so neat stuff. Let's go and talk. I talked about map and how you can perform the same type of calculation on multiple different values. Now I want to talk about filter, which is used to filter out values in an array. So let's go nums2 is equal to, and 1, and 2, and 3, and 4, and 5, and 6. All right, so there you go. You got an array. And basically what I want to do here is only get even numbers using filter. So I'm going to go even nums equal to, and nums2, and filter, and then define the filter. So we're going to go num integer boolean in, and then we'll define how we're going, the condition that's going to be met. And of course, to check that, there you go, got it. And now we can come in and just print out those even numbers. So even numbers, there they go. And you can see it filtered out only the evens. All right, so pretty cool stuff. Hey, why don't we talk about reduce also? Reduce is going to reduce an array of values into one value. So let's just have it sum all the values in an array. So sum 2. And we'll go and perform this operation on numbers 2 and reduce. And this is going to be the starting value for, you know, the final value. So it's going to start off at 0. And then we're going to go x integer, and y is also an integer. And this is going to return an integer in. And then what we're going to do is just, whoops, what did it do? And then we can go return x plus y, and it'll cycle through all the different values in the array and then add them all together. And then we can come in and just go print sum2, and you can see it went and added all those values. All right, so pretty neat stuff we can do there. Now I want to talk about enumerations. Now enumerations allow you to define types with a limited number of cases. So let's go and create one called emotion. And then we just list all of your different options. So we can say something like joy and anger and fear. Just stick with the inside out group here. Disgust and sad. All right, so there you go. You got them. Now you can assign a feeling. So we'll go var feeling is equal to emotion. And let's say we start off with joy. All right. Now we can, of course, change the value. So let's say we went from joy to anger. Well, there you go. Pretty simple. And you're going to be able to get the value out of this also. So we'll go angry and then go and get that feeling. So just go feeling equal to anger. And you can see it comes back as true. Okay, so very brief example. Just wanted to cover enumerations. And now let's talk about structs. Now basically structs are a group of related data. So let's create one here. Let's call it rectangle. And a rectangle is going to have a height, and let's make this 0, 0 by default. and a length. Let's also make that 0, 0. And you're going to be able to include functions inside of it to perform on here. So we'll go, let's say we want to calculate the area. We can do so. And this is going to return a double. And then we can go let area equal to height times the length, and then return our area. And then let's come down here and start working with our brand new struct. Let's create a rectangle. I'll call this my rectangle is equal to, and then you go rectangle, and then you define your height. Let's make it 10, and your length, and let's make that 5. And then we can come in and get the area for it. So let's go print and area. And let's also, I'll show you how to get the values out of it. Pretty simple, just go my rect height and multiply that times my rect and get the length is equal to, and then we will get the area from it. And you can just go my rect area and call that function, and it's going to automatically calculate that for you. And there you can see it went and outputted all that. Okay, so there you go. Example of structs. Now let's take a look at classes. And I'm sure you know what classes are. They allow you to try to simulate real world things inside of your application. So let's say we are trying to define an animal. Well, let's say that every animal is going to have a name, and we're going to start off with no name by default. And every animal is going to have a height, and we'll have this be a double and give it a value of 0.0 by default, and a weight, also a double, once again 0.0, and every animal is going to make a sound of some sort or another, and there that is, and we'll give that a value of no sound at the beginning. All right, so we're going to be able to assign those default values. And now to define those values each time a new animal is created, you're going to do that inside of init. So it's going to receive a name string and a height and a weight and a sound. And then we are going to define those things. So sound, there that is, and it's a string, of course. And then we can assign those values by using self, because we have no way of knowing what the name of the object is inside of the class. So self is a way of referring to it. So height is going to be whatever the height was they passed in, and the same for the weights, and the same for the sounds. So sound is equal to whatever the sound was. All right. Of course, real-world objects have more than just attributes. They also have capabilities, and those are defined by our functions. This one here is just going to provide some information on our animal. So I'm going to say print, and let's go and get whatever the name is. How you do that is go self name is, and then let's go get the height for it. So once again, self height, and let's have this be centimeters tall and weighs, and go get the weight for it. Whoop, make sure you put self inside of there. Got ahead of myself a little bit. And we'll say kilograms, and likes to say, and let's go and get whatever the sound is that we assign to it. And there that is. Okay, so there's get info. Another thing that is useful, this doesn't have anything to do with animals, but I'm just going to cover it here. You can use overloaded methods, and they allow you to basically perform different actions depending upon the different parameters that are passed in. So let's just do a simple one here that's called getSum, and number 1 is an integer, and this is going to perform addition operations on integers and return an integer. And of course, to have it work, all it is return whatever num1 plus num2 is equal to. Well, just by changing the data type of the parameters, we're going to be able to keep the getSum name, but we'll change this to double. And now it'd be able to perform actions on doubles as well, using the same function name as doubles. Whoops, make sure that's double. And there we are. And now let's go down here and let's test all this stuff. So let's create a function or a animal object called rover. And to do so, you go animal, and then you pass in things like the name, which is rover, and the height, which is, I'm going to say 38, and the weight is 12.7, and the favorite sound for rover is going to be roof. And there we are. Now we have our rover animal object. Whoops, I spelled name wrong. What is wrong with me? And there we go. All right, so now that we went and created that, we can then go rover and get info like that, and it's going to output all of that information. Wait a minute, what did it do? Oh, get info. There we are, now it's right. And then you can say rover 38 centimeters tall, blah, 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 blah. All right, so there's a very quick example of how we can use classes. And now I'd like to provide more information by covering inheritance. Basically, with inheritance, we are going to be able to define a class that is going to inherit all of the fields as well as methods defined by another class. So we're going to use animal, of course, and you're going to be able to create brand new functions inside of your new class, or override functions also. If, however, you would like to define a function that cannot be overridden, you mark it as final. So let's say that we demand that every single dog be able to dig a hole in a certain way. Well, we're going to do it that way, and so forth and so on. So let's come in and we'll just go like this, and self name, and then we'll say digs a hole. And there we go. We defined exactly how that's going to operate. And let's go in and override our function. This is how you do that. So we're going to override the getInfo function. And you're going to be able to call a method in the superclass. So we're going to be able to go super and call the getInfo function in the animal class, just like that. But then let's say we want to provide additional information, like we want to print and digs holes. We could do so. All right, so that's just a very simple thing. Now let's test out this stuff and show you how it works. So we're going to create another animal object. And let's just go and copy this. I don't have to type all that out again. So we're going to let's just do the whole thing, eh? So I'll go like this, paste that inside of there, and let's just call this spot. And here, this is going to be a dog instead of an animal. And we'll change the name to spot. Whoops, what did I do? And we'll change the name to spot. There it is. And let's just leave everything else exactly the way, or actually exactly the same way. And now you'll see if we type in spot here for getInfo, however, it's also going to print out and digs hole. All right, so you're also going to be able to pass subclass types. Another thing that is interesting is this is referenced as polymorphism, which allows you to pass in a subclass type as if it was the superclass and have the right method automatically called. So let's go and create a function that does this. We'll say print getInfo, and it's going to receive an animal, animal type, and then it's going to call getInfo on that animal type. What we're going to be able to do now is come up here and is go print getInfo and animal rover, and then we'll do exactly the same thing for spot, and you're going to see that the correct version of getInfo is automatically called. See, rover and spot, both of those work out perfectly. All right. You're also going to be able to come in here and change different values. We go spot name is equal to, let's say spot's now known as Doug. Well, there you go. You were able to change that easily, and I could print that out to prove it, but I think you trust me. Oh, and I was also going to talk about being able to use these functions up here, the get sums, so that we'll be able to add integers and doubles. Let's go and do a simple little rundown of that. And there that is. We're calling both of these on spot. You can see here, get some, except we're using integers here and doubles here, and you can see that those both work out. So there's an example of overloading. And the final thing I'm going to talk about with classes is how to check the class type. So is Spot a dog? And let's go find out if Spot is a dog. You can do that just by going Spot is, dog, right like that. And you can see it comes back as true. And also, you could come in here and go is Spot an animal? And that also comes back as true. So just some things we can do with classes. Now let's talk about protocols. Now protocols are kind of like interfaces in other languages, and basically when you adopt a protocol, you agree to define the different behavior that the protocol describes. So let's go and create one. Probably the easiest way. So we're going to call this flyable. Here I'm going to define if the getters and setters are going to be available for this. So I'm going to go flies and boolean and get and set. And then we can define the header for the function, but nothing else. Okay, so this is fly, and we'll say distance miles, and this is a double, and it's going to return a string. Now let's go and adopt multiple different protocols. So we're going to create a new class called vehicle, and it is going to be flyable. Going to inherit that, and this is yelling at me. No big deal. And then what we're going to do inside of it is go var flies boolean, and we're going to say that it is false, that this vehicle is not going to fly. And then we go and define name string and have this be no name. Whoops, make sure you put quotes around that, no name. Now we can come in and go function fly and receive the distance miles, which are going to be doubles, and return a string, of course, just like we defined above. And we'll say if self flies, return self name flies. And we'll throw in the distance miles as well. Distance miles, and then throw in miles. All right. Else, we're going to come in and say return and self name can't fly. All right, so now that we have all that set up, what we're going to be able to do is let's go and create a Ford F-150 vehicle, and then we can go Ford F-150, F-150, and define the name for it, which is going to be Ford, F-150, and then define if it flies or not. Flies, and I never saw one fly, so I'm going to have it be false. And then we can call print Ford F-150 and fly, and distance miles, and set that to 10. And you can see no matter what happens, it comes back as can't fly. And you can go in there and play around with that and check it out and see how you can work with protocols on your own. But I'm going to talk more about error handling. Now basically error handling is just going to be used to handle errors gracefully. So what we want to do here is I want to define an error by defining a type of the error protocol as an enum. So I'm going to show you how to create your own division error, and there is the error. And then we can define all the different potential errors that could show up. I'm just going to have division by 0 be the only one inside of here. You can have multiple ones also, just by adding more cases. So then what I want to do here is define that we want the error to get thrown from a function. And how you do that is, you go, well, I'm going to have this be divide. And this is going to be num1, which is going to be a float, and num2, which is also going to be a float. And then you're going to have to say throws if it throws an error, and then it also returns a value. Now inside of it, I'm going to put guard num2 is not equal to 0.0 else, and then I can throw an arrow or throw an error. So throw division error and divide by 0. Otherwise, we're going to say return the division. So there it is, and there it is. Okay, so that guy is going to throw that error. And now what we can do is try to trigger it. Now, if you want to protect from errors, you want to wrap your code in what is called a do try block. So I'm going to go do, and then I'm going to call try and call our divide function and throw in here num1. For num1, I'm going to put a value of 4. And for num2, I'm going to throw a value of 0 inside of there. Then after this, we can catch our error. So we can go catch division error, which is the custom error that we created. And then what we're looking for is divide by 0 specifically. And if we catch that error, we want to say that we can't divide by 0 and have that output on the screen. And you can say can't divide by 0 shows up. All right, so there is a quick example of error handling inside of Swift. Now I want to talk about extensions. Now basically, extensions are going to add new functionality to existing classes, structs, and other different types. And how you define them is you go extension. And what I want to do here is extend a double to work with different distance units. So I'm just going to go extension and double. And I'm going to set it up so that basically the double is by default going to be looked upon as meters, and then we're going to be able to convert to other different distance types using a dots index. So I'm going to also have kilometers inside of here, and we'll go double, and you'll see how it works. Pretty neat. Self multiply times 1000, and close that off, and then let's just go and get this like this and create a couple more of them just for the heck of it. Let's also do a conversion for meters, which is basically just going to return itself, because remember I said we want to have meters be the default. And then we'll also have feet, and in that situation we will multiply whatever the value is times 3.28. And then we'll also have inches, and we will multiply whatever that is times 39.37. I think I'm remembering that right. Doesn't really matter. All right, so we're also going to be able to come in here and add a method so that we can add additional functionality to double. So what I'm going to do is go mutating function square, and this is going to return a double. I can just go and calculate the square for this. Self multiply times self and return the square. And now I'll go and show you some examples and make more sense. So let's say I want to convert 1 meter into inches. I can do so. Let's go and have this be 1 meter is equal to 1.0 point inch. And then I can come down inside of here and go print 1 meter is, and get that guy, 1 meter. Oh no, that's uppercase. 1 meter inches. Whoops. Let's change this into inch. Messed that up. Now that'll fix it. You can see 1 meter is 39.37 inches. And let's also go in here and use our square function. So we'll go var random number 2 is a double equal to 5. And then we can just come in and go print and go square of 5. Random number 2, and call square on it, and it's going to automatically calculate that, which is also very cool. All right, so there you go, guys. That is an immense amount of information about Swift 3. Hope you guys enjoyed that. And like always, please leave your questions and comments below. Otherwise, till next time.